one big and one small, your total will always be the bigger number. Why? Because there's no way you can choose 15 if you have only 4, right? You have to choose 4 from the group of 15. You cannot choose 15 from a group of 4. So again, if you have only 2 numbers, the bigger number will always be your total, which is everybody see why this one is a combination, because they kind of spell it out for you in terms that the order does not matter. Agree? And again, once you have this, which is again the rest, your calculator, is how you input in your calculator. Your calculator should output the right number if you input it right? And if you look at number 2, in how many ways can you choose a corn if matter which flavor on top, which is in the middle, and which is on the bottom, right? So everybody see that now they want you have to picky and you say, oh, I want that on the bottom, this in the middle, and this on top. You are picky in terms of choosing your flavor, meaning specifically there are some order of the flavor you want, right? So because in this one you are picky, and that's why you have some specific order, that's why it's a permutation problem. And since it's a permutation problem, we know that we still have 15, right? The problem is the same problem. We have 15 flavor and we need to choose 4 of them, which is in this case, everybody see that I told you earlier that the permutation will always be bigger than the combination, okay? The order, specific order, they will always have more different way to choose it. So question with this one here, I think hopefully this one here is kind of a little bit easier than the horse racing, because not many people, the term of the horse racing and those are another language, right? But again, looking at this thing here, question with this particular problem. So we're good to determine if it's permutation or combination. All right, let's take a look at the next one. So here come the next item, right? So similar to the previous item, we have this thing here, a committee, right? The student counselor at a certain school have 15 members. So again, did I change it? 15 members. So again, 4 members will form a executive committee consist of a president, a vice president, a secretary, and a treasurer. So looking at this thing here, do you agree that this problem is similar to the ice cream, right? They just give you a different story behind it, right? Why they give you a different story behind this? Because why is the same? Because what is your total? You have 15. How many are you choosing? You choose 4, right? They just changing, instead of ice cream, you have some people that you need to choose. Now, number 1, in how many ways can this 4 position be filled? Versus number 2, in how many ways can this 4 people be chosen from the executive committee if it does not matter who get which position? So again, one thing that I mentioned earlier a little bit, that because they give you a title, everybody see that they give you specific title here in terms of president, vice president, secretary, and treasurer. If you took me 120, Math 120, and I told my student, if they give you specific title, or they give you specific ranking, or where something that in order of first, second, well, first, second, and third is ranking, right? If they give you something in that nature, then it's a permutation problem. If they give you in general, right? If this thing here, they say, oh, I have 15 people and I need to choose 3 of them, or I need to choose 4 of them. Doesn't matter who, I just need to choose 4. If it's so general, then it's a combination, okay? But again, because of this author, because of this book, he emphasized a lot in terms of order matter versus order doesn't matter. So most of the time, he will tell you something that if they give you the name and he don't say it, meaning this 4 position, the order matter. Right here, they say that does not matter, meaning again, doesn't matter who get which position, the order doesn't matter. So again, that's the one thing about this author is sometimes he write it out in terms of tell you spell it out, and then you have to recognize that, oh, he said that the order doesn't matter, so it's combination. In this case, which is again, after we figure out number 1 and number 2, do you agree that again, number 1 is permutation, which is 15p4, same as before, same answer as before, right? And again, the next one is again 15c4. The answer is the same as your ice cream earlier, right? So again, the answer, like I said, if you take everything out, if you take the story out, it's the same, right? They just give you a different story so that you can see that the item is different. So now, here comes the item that I mentioned to you guys, that what we just did was 4.4, ladies and gentlemen. And 4.4, that's it. 4.4, you recognize if it's order matter or order doesn't matter. Now, the problem come in is now they want to put everything together. They want to put 4.4 with 4.1 in terms of and 4.3 in terms of probability, right? So this thing here, they say 4 people on the student counselor are Sam, Justin, Brittany, and Rashad, right? What is the probability? What is the probability that Sam is a president, Brittany is a vice president, Justin is a secretary, and Rashad is a treasurer? So looking at this thing here, which is again, if you read this thing here, you say, oh my God, here we go again, probability, right? So looking at this thing here, this is what we have is we need to find the probability. So looking at this item here, let me ask you guys, do they give a specific order that they want?
Yes.
Yes. So we know that because they give a specific order, do you agree that this deal with a permutation, right? What order? Well, Sam have to be first, well, Sam have to be president, Brittany vice, and Justin is secretary, and Rashad is treasurer. Now, let me ask you, when we find a probability, what is the most important thing we need to do to find a probability? Remember, we need to find a total. Right. So how many total ways can we find 4 people have a specific order, right? Do you agree that 32,760 different ways that this 4 president, vice president, secretary, and treasurer can be formed, right? So now let me ask you, how many ways can we have Sam as president, Brittany as vice, Justin as secretary, and Rashad as treasurer? How many different ways is that? Do you agree that there's only one way, right? There's no other way. Brittany cannot be vice president. I mean, Brittany cannot be president, right? There's only one specific way that Sam have to be president, right? This specific order, there's only one specific way. Everybody see that? Which is in this case, looking at this item here, how do we find the probability? The probability of this thing here is we have 1 over 32,760, which is again, if you type in your calculator, ladies and gentlemen, I want to show you this here so that when you on your homework, if they want the decimal, you know how to adjust your calculator. If you type in your calculator, if you have 1 divided by 32,760, your calculator, because it's too big, your calculator will give you 3.0525 something, 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 times 10 or e to the negative 5, okay? What does it mean, e to the negative 5? Remember, positive, I tell you that you have to move the decimal to the right. Negative exponent tell you that you need to move the decimal. Everybody see that the decimal is right here, 3.053. I have to move 1, 2, 3, 4, 5. Everybody see that that is what I need to do, or that's what you guys need to do.
Yes,
if
sir.
you were to have a scientific notation and you need to move your decimal. If it's positive, you move it to the right. If it's negative, you move it to the left. Okay. So again, on Connect Math, some of them ask you for scientific notation. Some of them ask you for decimal. So make sure that if they ask you for decimal, don't give them scientific notation, because Connect Math will tell you it's wrong. If they ask you for scientific notation, don't give them a decimal. Okay. So again, that's basically what we need to do. And again, the next thing that they have, which is again, what is the probability that Sam, Justin, Brittany, and Rashad are the full committee? And again, there are 15 members, meaning there are the other 11 members, we don't know the name. Okay, so they ask you, what is the probability of this 4 become, again, doesn't matter who is present, who is vice, who is secretary, who is treasurer, we need these 4 people in the office. So how do we do that? Which is, again, same thing go. There is only one way that this 4 person get elected, right? We don't know which person, we don't know, but we know that this is the item we have, which is that one way, which is, again, to find the probability of this 4 get to the office is 1 over the total of the order doesn't matter, which is the 1,365, okay? Which is, again, this is what we have, which is 0.00. I think this one here, if they were to ask you this thing here, they will ask you more than 4 decimal place if they were to ask decimal place, okay? But again, this is basically the only thing left in 4.4 is they combine the probability with the permutation and combination. You have to find the total, which is how many total overall ways, and then what is the specific way that we can have. Let's try another one.
Mr. Tran, I have a question really quickly.
Yes.
For number 4, how did you know you needed to use the 1365 total?
Because they don't give you specifically who is who, meaning we don't know if Sam is a president. We just need these 4 people in the committee. Sam can be either president, vice, secretary, or treasurer, right? They don't give us specific order of who take what position.
Okay.
They just say, we want these 4 people, Sam, Justin, Brittany, and Rashad in this committee of this 4 position. Doesn't matter who is which one, as long as we have those 4 in, okay? And one thing is, you know, one thing is for this author is, you have to ask yourself, one thing is it there any specific way that he wants? If he don't ask you specific way, then it's just general. If it's general, combination.
Okay.
So let's take a look at the next one, which is, again, let's take a look at this thing here, which is same thing go. Let's take a look at the story, right? Keep your password safe. Let's do the next one first and come back to this later. Let me do the next one. Let me see. Let's do this one first, and I will come back to that password later. Password is a little bit different from this one here. So let me do this one similarly to the previous problem. A committee consists of 7 women and 9 men. 3 committee members will be chosen as an officer, right? So looking at this thing here, let me ask you, do they give a specific order that we want these 3 people to be chosen?
No.
Do they give a specific title?
No, it just said
No,
7 women and 9 men.
It's just that we have 7 women, 9 men, and we need to choose 3 for committee. Doesn't matter what 3, right? Agree? Which is, do you see that this thing here, because they don't give on any specific, they don't say first, second, third, they don't say present, vice, or anything, which is, this is just general. And if this is general, everybody see that this is a combination problem. Okay, so now, how many different choice, how many different ways can we make this possible? So the difference between this problem and the previous problem is, let me ask you guys, how many total people do we have? How many total people do we have here?
16.
16. Everybody see that we have 16 choosing 3, right? We have 16 people because there are 7 women and 9 men, which is the total people. There are 16, and we need to choose 3 of them, right? Which is, again, in this group consisted of 7 and 9, which is 16, and we need to choose 3 for this officer. Doesn't matter what the position is, therefore combination. How many ways can we choose this possible? How many possible way? Which is, again, 16C3, which is 16C3, we have 560 different ways, right? And again, looking at this thing here, and again, like hopefully you don't need me to type in the calculator. You guys can justify the answer by typing your calculator, right? How many different ways, how many different choice is possible if all officer are women? So looking at this thing here, how many women do we have? Do you agree that we have 7 women and we need to choose? We have 7 women and we need to choose 3 of them, right? Which is, again, everybody see that, again, for number 2, they asked us, yes, you say, wait a minute, Mr. Tran, now they specifically asked us for women, yes, but they specifically want just women, but they not ask you specifically the order of the 3 that you choose, right? So still the order doesn't matter, right? Who say, wait a minute, now we are specifying in terms of woman and man, but it's not, it's the order that we are looking for a specification, okay? So looking at this thing here, 7, because there are 7 women and we need to choose 3 of them, which is in this case 7C3, we have 35, which is, this is the number of ways choosing 3 women from a group of 7 women, right? And number 3, which is looking at this thing here, they ask you in terms of the man, which is we have 9C3, which is 9C3, there are 84, which is, this is the number of ways choosing 3 men from a group of 9 men. So everybody see question 1, 2, and 3, which is they just basically ask you in terms of how many ways can you form this group from this total. So again, the difference between this problem and the prior one is, the prior one, we don't know how many male or female in our group. We know we have 15 of them. In this case, they give you the male and the female by themselves. But again, you can add them together to give you the total over of the group. And then if they ask you specifically of each group, then you just take that group by themselves. So question with 1, 2, and 3 here. So now, let me ask you for number 4. What is the probability of all officer or woman? So what's the probability of me choosing all officer and all of them are women, which is, again, remember, to find the probability of all women, we need to find the number of ways that I can choose 3 women from a group of 7 over the number of total possible ways that I can choose 3 people from a group of 16, which is, again, the 16 C3 is the total ways, right? Doesn't matter if male or female, doesn't matter if it's all woman, all man, 2 men, 1 woman, 2 women, 1 man, doesn't matter. Is in that 560, which is, that is your total ways that you can choose 3 people from a group of 16. Now, to find this probability, which is, again, to find this probability, the number of ways that we can choose 3 women from a group of 7 is 35 over 360, which give us 0.0625. And now you probably say, oh, Mr. Tran, they throw this thing at me, right? Which is, they ask you at least 1, right? They ask you, what is the probability of you select this group, and this group have at least one man in it, right? So looking at this thing here, how do we find at least 1, which is, again, in the beginning of our lecture for today, to find at least 1 is basically you need to find a probability. You need to find the probability of at least 1 is 1 minus the probability of none, right? So 1 minus the probability of none. So what is the probability of none? Do you agree that probability of none of the member is a man? Probability of none of the 3 are men. Do you agree that it's the same way as saying that all 3 are women? Agree? What does mean the probability of none of the 3 are men, which is, do you agree that none of the 3 are men is the same as say all 3 of them are or woman, which is, this is the probability of a none right here, ladies and gentlemen, which is again, which is all you need to do is take 1 minus this, which give you 0.9375, which is again, hopefully you guys see that this thing here, they lead you step by step, right? How do we find, well, 1, 2, and 3, you have to do it. Step 4 is basically you use step 2 over step 1. And again, step 5 is you take 1 minus this. Why 1 minus this? Because the probability of 3 of them and all 3 women is the same as all 3 of them, and none of them are men, right? So again, the probability of none here is the same. And you say, wait a minute, Mr. Tran, why is not the same like before, where you take the probability raised to the power? The reason is not the same probability all the time, okay? This thing here is kind of dependent, meaning you select one person, that person cannot be selected again, right? It's one less, one less, one less, right? So again, it's not the same. Last time is the same probability, right? Flip the coin 50-50, right? Winning the lottery is the same probability all the time. This one here, the probability is different. That's why we're using this way, okay? We have to convert the probability of none to the probability of at least. None to the probability of all women. They say this, they say differently, but they mean the same. Hopefully that you see that is the equivalent. Question with this problem here.